So what we are going over is what I call solving for x, which hopefully you got a lot of practice with that already today. Again, in an ideal world, you know the initial concentration of something and the end concentration of that same thing, so you know the change, the x value, and then you can figure out everything else and do products over reactants here or there. The second question you would have done in that practice problem sheet, you had x values, but if you took the square root of both sides, now things can be solved pretty easily. There are some questions where it doesn't work out that well, and here is the example. So if you want to write this equation on your sheet of paper, the phosphorus pentachloride, by the way, PCl5 disobeys the octet rule because phosphorus is the third energy level, has access to d energy level, or d orbitals to store extra electrons. Remembering all that trigonal by pure metal shape. Makes phosphorus trichloride. PCl3 is going to be trigonal pure middle in the shape. This stuff hopefully coming back to us. Plus Cl2 diatomic chlorine. Gives you the K value of 4 at 228 degrees Celsius. Remember, K value is dependent upon temperature, because whether or not it's endothermic or exothermic can play a role then of the balance between products and reactants. Now, the only bit of information I'm giving you in this question is the first bullet point. The initial concentration of PCl5 is 0.5 molar, or 0.50 molar. My other bullet points are telling you how to solve the problem. You don't have to necessarily write those down, because I'm going to do that with you right now. Whenever you see an equilibrium problem, you have to realize you should be setting up an ice table. And not only for your own benefit, but quite frankly, when it comes time for the AP exam, the graders want to see that you do that. This is universally done for equilibrium math. Once we have that, we'll do products over reactants. And at some point, you're going to see that we're going to have to try to set everything to 0 because we can't simplify x very easily. I'll remind you of the quadratic formula, and we'll get to the answer in a little bit as well. So, again, if I switch over to Smart Notebook then, here's what we're given, and I'm actually going to cut that out right now, because the first thing I want to do is an ice table. And in the problem, given 0.50 molar of the PCl5, which means I start off with 0 of the other two things, because if they're not mentioned at all, that's what I'm starting with. You don't have to do a K versus Q like you had to do on one of the practice problems you did just a little while ago, because if you only have reactants, you know the reaction is going to the right. In other words, the change, the C in my ice table is a minus X for the PCl5. And since it's a 1-to-1 ratio stoichiometrically, plus X and plus X are the values of the two products. For every 1 PCl5, there's 1 PCl3 and 1 Cl2. Too often students want to put like a 2X for the PCl5 or for the other things, where it's a 1-to-1 ratio.
So like if the Cl2 had like a 2 coefficient, you just do plus
2x.
2x.
Yep. So you basically, X is I don't know how much, and then look at the coefficients. Then you combine your I and your C to make your E. So at equilibrium, I'd have 0.50 minus X, I'd have X, and I'd have X. There's step 1 of my bullet points of make an ice table. Okay. If we were to solve for K, it would be the concentration of the PCl3 times the concentration of the Cl2 divided by the concentration of the PCl5, which in this case is X times X divided by 0.50 minus X equals the K value of 4.0. Again, if you got to question 2 on the last worksheet that we did, it actually worked out nice where if you took the square root of both sides, you got X by itself, more or less. Can't do that here. It doesn't work. Because if I first off simplify, x times x is x squared. I could try to take the square root of that, but then the denominator square root, you don't ever want to be in a position where you have x to the 1/2 in this class. Maybe in a math class you're okay with that, but you should not feel comfortable with that when you're trying to get to our answers here. So instead, what I have to do with, again, this over here, x squared over 0.5 minus x times 4.0, is I would first try to get rid of the denominator. I'd multiply both sides by 0.50 minus x. Because that way I can get rid of some of this fraction work. And I'll simplify that for you. So if I took 4.0 times 0.5 minus x equals the x squared, and multiply both sides by the 0.50 minus x, that'd give me 2 minus 4x equals x squared. Hopefully you're taught in a math class that if you have something like this, you need to get everything to one side and set it equal to 0. I usually prefer to keep my x squared value positive, so I'm going to take the things on the left side of the equality and add the opposite version to the right side. So I'm going to have 0 equals x squared plus 4x minus 2. If you're lucky, you could factor this out. We know factors, right? X plus something times x plus something. You're not going to have that in this class. Instead, what you're going to have to do is the quadratic formula. For those of you who don't remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you do it to a song, you're more likely to remember it. There are only a few calculators that are not allowed by the College Board. Most of them are. And most of them that are allowed, you can program things in. I think you're supposed to maybe clear it, but I don't know if you actually have to or not. Because I can't actually be in the room when it's being administered. Because me just being in the room is going to make you more likely to do well in it. It's diffusion of knowledge, ladies and gentlemen. High concentration to low concentration. I've told students that, hey, if you're good at your calculator and you want to program this into your calculator, you go right ahead and do so.
Wait, so if we do that on a test, do we actually have to write out? Like,
You're just going to show your work. You have to, what the College Board would say, demonstrate an understanding, yes. All right. Now, if you are not familiar with quadratic formula, the number in front of the x squared, which is assumed to be 1, is your a value. The number in front of the x is your b value. The number without a variable is your c value. Don't forget to take into account that it's a negative value here. So if I plug all this in, I'd have negative 4 plus or minus, so I have to do both. 4 squared minus 4 times a negative 2, all divided by 2. If you do this, you would get two values, 0.45 and a negative 4.45. In the quadratic formula, you have the plus version and the minus version, so you're going to get two numbers. Now, in your math class, when you are taught the quadratic formula, you get two values, you're happy, you're done. Not in this class. Unfortunately, in applied mathematics, like chemistry and physics, our numbers have to make sense and not just be the final answer. And one of these numbers does not make sense. Because if I go all the way back up to my equilibrium expression, if I plug in negative 4.45, one of my x values, that means at equilibrium for the PCl3 and the Cl2, my x is negative 4.45. There's no such thing as a negative concentration. That number does not work. On the other hand, I could plug in 0.45, and that could give me two values for my products. 0.50 minus 0.45 gives me a number that makes sense as well. So that's why this is the number that has to be the correct answer. Now, you could be asked then to solve for the concentration of each thing, plug that into X.
Will it ever happen where there'll be two positive values?
There could be two positive values, but what will happen is maybe one of those positive values will be bigger than 0.50. So always one of the two won't work.
Okay.
So even if you can plug it into your calculator, you still have to do a little thinking beyond that still. Like I said before, this will not be on multiple choice. This will be on Wednesdays. I guarantee I'm going to do it once to you the entire year, and that's it. Because me and Jade were actually having a conversation about K values earlier. A K value of 4 is kind of unique. Usually K values are either really, really big or really, really small. In the next unit on acid-base chemistry, the K values are really small. And there's a shortcut I could show you that can avoid the quadratic formula. But it only works when the K values are really, really small. So most application of equilibrium is going to be done next unit. For now, I do need to know how to do that.